Student, you know that feeling. You're in an exam, the clock is ticking down, and it feels like a constant weight on your shoulders. Today, we are going to tackle one of the most critical skills for absolutely acing your circuits exam, choosing the fastest analysis method. Look, this isn't just about getting the right answer. It's about getting it before you run out of time. So let's build a strategy that's going to give you back those precious minutes.
Just picture it. You're in a computer-based exam. A pretty complex circuit diagram pops up on your screen. Your mind starts racing through, half a dozen analysis methods? Nodal, mesh, Thevenin, superposition. They all could work, right? But only one of them is the fastest way to get to the solution. The pressure is on, and the choice you make right now, well, that's going to decide the next 10 minutes of your life.
And no, that's not an exaggeration. In a typical 60-minute exam, picking the wrong method for just a single question can cost you up to 10 minutes. That is a huge penalty. It's the difference between finishing with confidence and just frantically guessing on the last few questions. So let's build a strategy to get that time back. Okay, we're going to start with the two foundational workhorses of circuit analysis, nodal and mesh. You should think of these as your primary go-to tools. 90% of the time, one of these is going to be your best bet. But knowing which one, well, that's the secret sauce. So here's the crucial point, the trick to it all. It really just boils down to a simple count. Before you even think about writing a single equation, just count the number of essential nodes, and remember, that's any point where 3 or more components connect. Then, count the number of meshes, which are just the independent loops in the circuit. Whichever number is lower, nodes or meshes, that's your clue. That's the method that's going to give you fewer equations to solve, which makes it the faster choice. Simple as that. Let's get a little more specific. Nodal analysis, it's all built on Kirchhoff's current law. The idea that the current going into a point has to equal the current coming out. This makes it your go-to method when you see a whole lot of parallel branches, especially if they're all connected to a common line. And it absolutely loves current sources because they often simplify your equations almost instantly. And hey, if you see a voltage source just kind of floating between two nodes, that's your cue to use a supernode, which is a great little shortcut that combines two equations into one, saving you even more time.
And on the flip side, we've got mesh analysis. This one is based on Kirchhoff's voltage law, the rule that all the voltage drops in a closed loop have to add up to 0. Now, mesh really shines with what we call planar circuits, the ones that look like clean little window panes. It handles voltage sources with no problem at all. So if your circuit just has 2 or 3 clean loops, mesh is often the most direct route. And what if a current source is shared between 2 of those meshes? Not a problem. That's a signal to use a supermesh, which is just a clever technique to bypass the unknown voltage across that source.
Okay, let's move on to our next set of tools. If nodal and mesh are your workhorses, you can think of Thevenin and Norton's theorems as the smart cuts. They are specifically designed to take a complex, messy part of a circuit and just reduce it down to something incredibly simple. The whole philosophy behind Thevenin's theorem is captured perfectly by this idea right here. When an exam question only asks about a single component, what we call the load, why on earth would you solve for everything else? Thevenin lets you just surgically remove all that complexity and focus only on what actually matters. And this whole process is just elegance itself. Step 1. You mentally take out the load resistor. Step 2, you find the open circuit voltage, V thou, and the equivalent resistance, R thou, of whatever circuit is left behind. And then step 3, you create a new, beautifully simple circuit with just V thou, R thou, and your load. This is an absolute game changer for problems where that load resistor keeps changing values, because you only have to solve the complex part one time. And you can't talk about Thevenin without talking about his trusty companion Norton. It does the exact same simplification, but it gives you a current source in parallel with a resistor instead. The real power here is the direct relationship between them. Once you have the Thevenin equivalent, you can get the Norton equivalent almost for free, with a simple source transformation. It's just Ohm's law, IN equals VTH divided by RTH. It's a fantastic alternative, especially for those circuits that are heavy on parallel components. All right, now for our specialists. Superposition and Millman's theorem aren't for every day, but in the right situation, oh man, they are unbelievably powerful and fast. These are the special tools you bring out for very, very specific circuit layouts. This is the core magic of superposition right here. It's for those circuits that have multiple independent sources, like a few batteries and a current source all working at the same time. So instead of trying to solve that messy combination all at once, superposition lets you turn off all the sources but one. Solve that now simple circuit, and then just repeat that for each source. Then you just add up all the results. It's beautiful. One hard problem becomes several easy ones. So when do you use it?
You pull it out when you see multiple source types, and the circuit would become, trivial if you only had one source active at a time. But, and this is a huge pro tip, so listen up, this is the one that will save you from a really common mistake. You can never use superposition to calculate power directly. Power formulas are nonlinear, so you absolutely must solve for the final total voltage or current first, and only then do you calculate power. You got to memorize this. It's a classic exam trap designed to catch you off guard.
And finally, we have the most specialized tool of all, Millman's theorem. There's a very specific visual cue for this one. If your circuit looks like a parallel bank of batteries, and what I mean is multiple branches, each one with a voltage source and a resistor, all connected between the same 2 points, then Millman's is your weapon. It gives you that common voltage across all those branches almost instantly, letting you sidestep a bunch of messy equations entirely.
All right, we've covered all the tools. Now, let's put it all together. We're going to build a lightning-fast strategy that you can use the moment a circuit appears on your screen. This is how you're going to win back those 10 minutes.
Okay, this right here is your mental cheat sheet. Before you start writing anything, you're just going to run through this checklist in your head. Do you see mostly parallel branches? Your brain should immediately jump to Nodal, or maybe Millman's. See a bunch of clean series loops? That's a clear signal for mesh. Does the question ask about a single load resistor that keeps changing its value? That's a huge red flag for Thevenin. Multiple sources in a simple layout? Superposition. This table connects the look of a circuit directly to the best method.
And here it is. This is the single most important takeaway from this entire explainer, the 10-second rule. Before your pencil ever touches the paper or your hand touches the mouse, just take a deep breath and look at the circuit for 10 seconds. Do that simple count we talked about. If you see 3 messy loops but only 2 essential nodes, you go with nodal analysis, period. It's an investment of 10 seconds that can save you 10 minutes of painful calculations.
So I'm going to leave you with this question. After all this, the next time you're faced with a complex circuit, what are you going to see first? Not just a tangle of resistors and sources, right? You're going to see a pattern, a clue. You're going to see the fastest path to the answer. And that is how you walk into your next exam with total confidence.